is absolute value. Yes. You see like the vertical bars, and it measures distance from 0. Distance has to be positive, of course, so that means absolute value is always positive. Properties of absolute values that we need to know. If we're going to solve equations with absolute values, if I say like the absolute value of A equals B, then you have to write two equations. A equals B, or A could equal a negative. Since absolute value makes it positive, the original could have been positive, or it could have been negative. The same is true. You might see equations that have absolute values on both sides. That doesn't matter, we treat it the same way. You set the two equal to each other, and then you set it equal to the negative. Okay, you don't have to solve 4 different possibilities, it's just the 2 options. They're either equal to each other or they were opposites of one another. All right, with inequalities, when I say the absolute value of A is less than B, less than, you think and. I think Mrs. Keller used this trick sometimes. She talked about less than. So it's an and statement. What you do to write this thing without the absolute values is you are going to sandwich the A in between the negative and the positive. So you're going to write negative B is less than A is less than B. The last option is greater than. I think she used to say greater than as kind of your trick to help you remember. That's like an or statement. So what that means is either this piece is true, A is greater than B, or for the negative one you have to flip the inequality. A is less than negative B. So on the equations, you just do 2 equations. With the inequalities, you have to watch if it's a less than or a greater than, and that changes your approach on how you solve it. On any of these problems, equation or inequality, you have to isolate the absolute value first. So before you separate it and write it without the absolute value, get it on the side by itself. That's our first step. So let's just try some equations. Start with equations. I already said all that. value, but it is. So we can go straight to writing the problem without the absolute value equations in it. So we just drop the absolute value and you make two separate equations. 9 minus 4x equals 7. And 9 minus 4x equals negative 7. Solve each of them. So subtract over your 9. Divided by negative 4. And I get a positive 1/2. Second one, subtract my 9. Gives me negative 16. Divide by negative 4. And I get positive 4. Two equations, but be careful. The first one, you just drop the absolute value. The second one, you drop the absolute value and you make it a negative. If I write it like this, is that correct? No. That negative has to apply to that entire side of the equal sign. So you are going to have to distribute the negative to both terms. Okay, so then if we solve, if I subtract over my x, subtract my 2, divide, we get negative 7 over 2. We distribute the negative. Add my x over. Subtract the 2. And we get 3/4. Again, given the choice between fractions and decimals, I prefer fractions in lowest terms. Can you check these? 1 and 2, could we? Yeah, just plug them back into the original. It should work out. So you always have that option. I'm going to put one up here for you guys. So here is your problem. Solve that. Have to isolate the absolute value before you make your two different equations. Otherwise, your answers will be off. So then you do your two equations. Subtract your 6. We get x to be 2. And positive 4. If you didn't subtract first, you would have gotten one of the answers, but not the other one. Okay, let's do some inequalities. first, isolate the absolute value, which it is. Second, if it's an inequality, we have to ask ourselves, is this an and or an or statement? Less than is an and. That means we make one big inequality. So you put the negative less than 2x plus 1 less than 7. Do you guys remember doing this before? That's probably the hardest step right there, just remembering how to set it up. From here, it's solving that inequality like we were doing in the last section. So we subtract our 1 from everything.
Pardon the interruption. One more call. All seniors and underclassmen who have not had your regular classroom picture taken, you need to report to the library at this time. All seniors and underclassmen who have not had your regular classroom picture taken, you need to report to the library.
How do I want you to write your answers? Interval notation. So if I asked you to graph this, could you? Interval notation, this is starting at -4, it's not equal to, so it gets a parenthesis, comma ends at 3. So 3 will get another parenthesis. So for B, I actually did the exact same problem, but I just flipped the inequality. I just want to show you what the difference is between a less than and greater than. When you set this up, greater than is an or statement. So you make two separate pieces. The first one, the only thing that changes is you drop your absolute value. The second one, you flip the inequality and make it a negative. So when you do the negative, the inequality flips. And we subtract our 1, divide by 2, we get x is greater than 3. And x is less than -4. Greater than 3 looks like this, less than 4 looks like this. We have to write the two pieces together. So the interval notation going left to right would be -infinity to -4 union 3 to infinity. You notice the difference in how these answers look? The less than, we had one piece. It was just in between these two numbers. The greater than gave you the or, so you got the ends, the two separate pieces. So less than you should get 1, greater than you should get 2. I'm going to show you just a couple more of these. Make sure we're okay with it. So what's the first step? Add the 1. Okay, second step, is this and or? Or, greater than. So we're going to do 2. The first one, you just drop your absolute values. Or for the second one, you flip it, make that a negative. When I solve, subtract my 2, What happens when I divide by my -7? Flips the inequality. Same thing here, divide by the -7, so it flips my inequality. Everybody okay? Okay, where did we? Yeah. Thank you for saying something. I did that on purpose. I just want to make sure somebody would speak up. Did I say add the 1 and then subtract it, or did I don't know. So then add the 1, so that's a 5. Subtract the 2, so it's a 3. Divide by the negative, so that flips it. So -3/7. That should be a -5, subtract 2, and divide. Thank you. Okay, so we write our integral notation. What does this piece mean? How would that look as an integral? And then the second piece? If you're struggling with writing that, take a second and draw yourself a number line and look at the graph to help you. Why don't you guys do B? Make this one less than or equal to. So first we subtract our 6. Is this an and or an or? And, so we put it in between the negative and the positive. Okay, subtract your 5 from everything. Divide by -8, which does what? So my integral notation, we have equal to, so that's brackets. This says x is smaller than 13/8 and bigger than -3/8. When you do integral, you have to go small to large. So I have to list my smaller number first. So it would be -3/8, comma, 13/8. And that's our final answer. I have one last slide and then I'm done for today. These are just a couple similar but have a little trick to them. On A, it's an equation. We always said it equal to a positive and a negative. Is there any such thing as positive and negative 0? So how many equations do we end up solving? Just one. By 7 and we just get negative. B. Does anyone notice anything about this? Greater than means we would do 2. The 2 is negative. Is that what you said when you said 2? Yeah. Okay, so what does that mean? Well, we can't, you still have to isolate your absolute value first, so let me start there. If you have a negative on one side, you can't just stop. You have to isolate your absolute value. But then let's just think about this. An absolute value is what kind of number? Positive. When is a positive greater than a negative? Always. So do I even have to solve this? No. What could I write down? So, if you have an absolute value by itself and one side is negative, your answer is either going to be no solution or negative infinity, positive infinity. If you catch that, it saves you a lot of time trying to work it out. If you didn't, if you worked out this whole thing, just have a random line there. So it would be an or. You don't have to write this out, but. I didn't change my sign on that one, did I? That should be my positive too. Because you always book the inequality on the one you change the sign on. If you graph that, 7/6 is here, 11/6 is here. You're bigger than the 7/6 and smaller than the 11/6. What got shaded? Everything. So it's all real numbers. So if you didn't catch it, you would find it out later on. But it's easier if we can see it at the beginning. So what about C? So how is that one different than B? It's less than. We know an absolute value is a positive number. So when is a positive number smaller than a negative number? Never. So you could just say no solution and never have to solve that one. Okay, so just be aware, if you see a negative after you've isolated your absolute value, you can probably just write down the answer from there. You just have to think through it. Do you guys have any questions for me? Okay. So, assignment for today. It says 1 through 8 are just matching, so there's only a few that you are actually solving. This is Tuesday. Tomorrow is Wednesday. What I am going to give you, normally I would have done a quiz over section 7 and 8 at this point. When I'm only seeing you 2 days a week, I'm not going to take one of my 2 days to give you a quiz in class. So I am just going to give you this as a take-home quiz again. So it's kind of a quiz, kind of not really, but I will be grading it like a quiz. So tomorrow on your day at home, you finish this homework if you don't have it done, and do the quiz. Thursday, you guys that's your online day, so I am starting chapter 2 that day. I was going to give a notes handout, so I'm going to go ahead and pass that out to you guys as well. So you'll have it, and we will still be working on that section Friday when I see you again. So. I'm actually kind of jumping to the middle of chapter 2. We're going to 2.3. So you have the rest of the hour, quite a bit of time to work on this homework and ask questions if you need it. And I will be handing